he is saving trucking companies 3 to 5% in fuel. And welcome to the Trucking Risk and Insurance Podcast, where this week we have Brian Livingston on the show. Brian is a chemical engineer, but his gift is he's able to explain complex chemical reactions to a simple guy like me, and I can understand it. And he is saving trucking companies 3 to 5% in fuel. Stay tuned. The show is next.
Welcome to the Trucking Risk and Insurance Podcast.
How to manage the safety department like an expert without the 30-year learning curve. If you want to lead the safety department like a veteran and you don't want to spend years in the hot seat learning it the hard way or decades of trial and error, text the word SUCCESS to 365-364-0714. Hey, Brian, welcome to the Trucking Risk and Insurance Podcast. Can you take just a minute and introduce yourself, please?
Yeah. Hey, I'm glad to be here. Yeah, Brian Livingston's my name. Company is Zelcam at zelcam.com. And I'm excited to be here today just to talk about trucking issues, but mostly about how we can do a little better with saving some fuel, making a little less CO2.
Mm-hmm. Well, I mean, I'm amazed at, the notes that you sent me that you can save like 3% of fuel. Is that right?
Yeah, I mean, in all the trucking tests we've done, we usually say like 3 to 5%. And, if you take all the average of the test, it's a little more than that, but I like to be a little conservative, under promise and over deliver,
Mm-hmm. Yeah. Mm-hmm. And can you explain a little? I know your background, you spent like 20 some odd years at Caterpillar.
Yeah, just about 20 years at Caterpillar, mostly in the diesel engine and transmission drivetrain area. So yeah, I'm kind of a diesel engine guy.
And you're a chemical engineer?
Yeah, that's what I got my schooling in, and spent, a lot of my career chemical kind of things, or mostly that project management throughout my career and such. And then my last 20 years with Caterpillar, kind of had to remember some of that chemistry again.
I'll bet.
And then with what I'm doing now, is even more chemistry than probably I've ever had in my career, really. But I have fun explaining it to people. I've drawn up some cartoons on how this thing works with molecules and whatever, and it helps people understand, because I just never want this technology to be like some black box that is, it's just magic. Just trust me.
Yeah. Well, so if we were to ask your wife, would she admit to that you guys have chemistry?
Oh.
Well, on a personal note, we've been married 40 some years. We kind of agreed to just quit counting at 40. It's been a great marriage, a great ride. So yeah, we have
it takes chemistry to last that long. There's no doubt.
Yeah, it takes some commitment, and some God's grace too.
Yeah, since I had a practice wife and now I'm married, I understand that. But anyway, chemical. What is it that you do today? How do you use your chemical engineering? And by the way, I can't speak for John, but when it comes to this stuff, I'm pretty uneducated. I was going to say dumb, but too many people would agree with that statement.
Yeah. You've got too many likes down below.
Yeah. So you've got to keep it simple for me. But what's your job? What's the company doing in the way of chemicals, and how in the heck are you reducing or saving 3 to 5% of fuel? Because that's a hell of a lot.
Well, it really is. Okay, I'm going to grab a prop here, guys.
Yep.
This is essentially, the technology, and it looks just like a copper tube filled with something, because that's essentially what it is. Inside the copper tube, we have all kinds of rare earth catalysts, platinum, rubidium, whatever, very expensive kind of things, rare earths. And as diesel goes in one side, inside you get this catalytic reaction that basically breaks down some of the longer chains of diesel fuel into shorter chains. And that's what you get out here. Not all of them, of course, but enough to make a difference. And I think we all remember from our high school chemistry that shorter chains, hydrocarbons, are going to burn easier than longer chains. And so there's really I almost said the magic of it, but I don't want that word because it's not magic. It's just plain old chemistry and physics.
Sure.
So that's the chemistry and physics of it.
It sounds
And so when it gets into your cylinder, then it just burns more efficiently because you've done some of the breakdown before it gets there. So you can put more energy pushing the piston down and less breaking up those molecules, essentially.
No, I'm liking it. I guess it's almost like you're changing the molecular structure of it a little bit. I guess, is that the idea?
Well, essentially we are. Yeah. In the refining business and anything dealing with hydrocarbons, they call it just cracking. You just take that long chain molecule. It's really just a bunch of carbons, carbon atoms with hydrogens, and you just kind of split it somewhere in the middle. And to get two shorter ones. And that's just called cracking in their world. And that's essentially how it works. I mean, there's some other things too. I mean, some of it does, go into a ring. Then if you have some loose ends, you can turn your molecule into a ring, like a cyclohexane or something. And I don't want to see anybody eyes glaze over here, but then that does release a little bit of free hydrogen, right? If you think about it. And I've got some great cartoons. So if anybody wants to, get on a call with me, that'd be great. And I can explain that. But anyway, you get a little bit of free hydrogen as well. And then that hydrogen makes a nice little pop inside the cylinder. And there's been a lot of studies on this. And I know I've seen some other devices where you try to add hydrogen in. And there's a lot of good reasons why they do perform, but trying to keep them alive and all that, from what I understand, has been kind of hard. So it's not there's nothing magic about this. There's nothing new. It's been around for a while. Other people have tried things. So, yeah, I mean, no magic, just physics and chemistry.
So, and fuel savings, don't forget.
3 to 5% is what we see. And there's something else now in the trucking industry, at least in North America. This is not terribly important because everybody's meeting all of the EPA rules and stuff. But we do lower the other kinds of emissions because you're burning more efficiently. You've got less soot and you've got less carbon monoxide and some of those other nasties. But again, all of our trucks these days, unless you've got a very old one, you've got all that Tier 4 final stuff on it that's removing all that down to levels that are required. So, perhaps for, North American truckers, that really doesn't matter. But for around the rest of the world, people are finding this technology to be a big help because, I mentioned it reduces soot. It's maybe about 50%.
Oh, wow.
Yeah, so I mean, if you've got a DPF on your truck, which most of us do here, in this continent, that means fewer regeneration cycles, which does mean longer life.
Right.
I don't have any data on that. We've never done any quantitative studies on that, but just directionally, that's got to be right. But other parts of the world, they're using this as significant emissions assistance because they don't have the strict laws. Other countries that don't have some stricter laws, like those of us in North America, we're able to help them. Like, if you're just not blowing a lot of soot out your exhaust, that just lets people know you're a lot cleaner.
Right.
Even sometimes just the visual aspect just gets you a nice boost in public perception, et cetera.
Sure. Would this also be applicable for diesel engines and other applications other than just highway road use?
Oh, absolutely. Because, as I tried to explain it, you really change the fuel. You don't change the truck. You don't change the engine. You just change the fuel. That's why you don't even need to do a recalibration or anything on your engine. And so actually some of our bigger, I'd call it low-hanging fruit perhaps, has been in the mining industry because mining industry drinks a lot of diesel. We've done this into locomotives, rail industry, port equipment, shipping, gen sets, electrical generation. Yeah, just
So
anything that
cool.
uses diesel. Yeah, it's a
Yeah.
pretty neat technology, you know.
Well,
Yeah.
especially when you're talking. So, Chris has pointed out the fuel savings there, but the emissions aspect, being able to cut your soot by 50%, because we know that soot is, the evil of all evils here. Not only just from inhaling it, but just from it makes your engine dirty and everything else. And so I'm going to kind of go off on a little side step here. I have a diesel vehicle. It's a Jeep,
Okay.
2014 Jeep with a VN diesel in it, and I have just shy of 430,000 kilometers on it. So
Okay.
260, just under 300,000 miles. I just had to replace the intake on that vehicle because it was caked in soot. And there's
Mm,
no way to clean it. And they say this is all due to the emissions on the vehicle because it's not blowing out and through, right? So, and my DPF filter has been clogged up several times and has to do a regen. It does it more frequently than usual. And I'm sitting here scratching my head going, wonder if this would work on my Jeep.
well, glad you asked. But the answer probably is it will work, yes. But would it be economical? Perhaps not. Um, on a normal over-the-road truck in North America, I'm south of the border here, so I'm talking
Yep.
miles. So,
Yep.
about 120,000 miles is kind of your average, truck.
Mm-hmm.
And the technology, when you buy it and install it, it's going to pay back in about a year. At
Mm-hmm.
today's diesel prices, so 100% return on investment,
Mm-hmm.
pretty decent. But it would be far less than that on your Jeep. Because even though we would have a smaller model we could sell, you just don't burn enough diesel, unless you're driving coast to coast all the time.
Right. But one thing I'm going to look at from a maintenance aspect for me to change that intake manifold and update it just cost me $4,000.
Yeah,
So,
yeah,
and they're saying, like again, I've got 400,000 kilometers on the truck itself, and I plan to carry on. It's a great engine; it works great, and they're going. You'll probably have to do this again in about another 400,000 if you get that far. So there's where I'm kind of looking at, not so much from an economical on the amount of fuel I would burn, but maybe that overall maintenance aspect and DPF filter clogging opportunities and stuff along that line.
Well, one thing we talk about when we're talking to prospective customers and such is this will make your oil last longer because you're
Mm-hmm.
taking the soot and a lot of the VOCs, or what, volatile organic carbons, volatile organic compounds. You're taking a lot of those out because you're burning more efficiently, and those are the two things that trash your oil, right? Is the
Right.
soot, and then the organics in it.
Right.
And so if you've got fewer of those going in, your oil's going to last longer. Um,
Yeah.
I mean, coming from my background, by the way, my background is I did spend almost 25 years, no, excuse me, almost 20 years with Caterpillar in their diesel engine division. And we always encouraged people, and I still do, to change your oil not so much by miles or kilometers, but by oil analysis.
Mm-hmm.
And when you get to doing this with an oil analyzer, you'll see that your oil is going to stay cleaner longer.
Mm-hmm.
We don't really factor that into the, financial calculations or anything. I mean, if a customer wants to, that's fine, but that's really hard to prove. The same thing with,
Mm-hmm.
making your DPF last longer and all that. It's, it's just harder to prove that. Oh, another thing that's hard to prove is when you take that soot out, you reduce, you don't eliminate, but you reduce the amount of wear on your rings, your pistons, valve train, all that kind of stuff because you're taking soot out.
Sure.
So your engine lasts longer.
I was just
On
going to say you've got that longevity aspect as well as an economical
yes,
approach.
yeah, and some customers that have used these for a number of years, they'll get like 50% more life out of
Oh
their engine
wow.
before you do it. Yeah, before you do like a top end overhaul.
Right.
Yeah.
Wow. See now
Yeah,
this is really becoming cost effective when you start breaking it down in that approach. Chris
yeah.
unfortunately will never use this device because he doesn't suck or blow diesel. He doesn't even have emissions. He's so pure in his way. Look at him. He just looks so pure. He's beautiful that
Angelic
he'll never
almost.
have
Yeah.
this. I know. Yeah.
He's just taking a shot at me because I have an electric car. But it is, just remember, nothing is emission free, even
Well, that's right.
electricity.
Yeah,
Sure.
yeah. You pay me now or pay me later.
Yeah.
Somewhere
Yeah.
there's
Exactly.
emission.
Yeah.
I mean, I'm not against electrics. There's a
Yeah.
lot of electric trucks coming online now, or at least a lot of
Mhm.
experimentation
Mhm.
going on with it. And I'm not against those things at all. I'm all for it. One of the things that when I get a chance to talk publicly, I mentioned, why don't we do what we can now while we're waiting for the ultimate
Mhm.
solution? Whether that's
Mhm.
electric, whether it's hydrogen, whether it's ammonia, whether it's who knows what.
Yeah.
Um, if we can do this now and have a payback in less than a year in the trucking world, and then
Mhm.
in the mining world and other areas, way less than a
Yeah.
year. Why don't we do that now? It's going to pay
Mhm.
itself over and over again by the time we get to our ultimate solution.
Mhm.
So
So,
that's one of the things I kind of harp on. I preach on a bit.
Mhm.
so this is a device that you can add to an existing truck. You don't have to purchase it through the dealer or anything like that.
No, that's one of the beauties of this thing. It's super easy for a retrofit. You basically just put this into your fuel line somewhere as close as you can get it.
Mhm.
Up towards your injectors, just after your high pressure pump, because most of us would be running um, high pressure fuel systems. So somewhere before you get into that high pressure pump, you run this thing through. And so you basically just have some threads on the end here you tie into,
Mhm.
tap into, and away you go. I mean, really, we say you can install this thing in a half hour, maybe an hour the first time as you're trying to figure out where you're going to mount it on the
Mhm.
engine and
Mhm.
hold it steady and everything. But after that, the rest of your fleet is just bam, bam, bam.
So I'm listening to you describe this 35% fuel savings, but I got to imagine, and you said it's hard to quantify, but there's got to be a significant maintenance savings.
There is. But one of the reasons I say let's not count that is if you've got a solid fuel reduction project with a 12-month payback, you really don't need anything else to make it fly, because there's not many CFOs that have 12-month projects sitting on their desk waiting to be approved, and so you don't really need it, and it's just hard to prove. I have a lot of data, and you can believe my data or not believe my data, but it's going to be tough for you to prove it um, in your operations. And so just don't count that. Just when you're spending less on maintenance over the next 5 years, 10 years, or whatever, just count that as frosting on the cake.
Uh, just brings up a different question. How long does your device typically last once installed?
Yeah, great question. Um, Forever.
Okay.
you know, yeah, yeah, no, nobody's going to believe that answer. It's like, okay, I have a bridge to sell you in Brooklyn, but uh, no, essentially, it never wears out because you don't dissolve all those rare earths into your fuel, and it's not really part of the reaction. Again, if somebody's really interested, get in touch with me and let's have a call. I can show you some cartoons I've drawn up,
Mhm.
and there's some great videos about how I like to think of these rare earths um, catalysts as like hydrogen magnets. It basically grabs the hydrogen atom off of the molecule, and then the molecule kind of splits apart, but then it gives that back just like a magnet would, and that gives you then it never wears out. It's just kind of like a magnet. You can use it over and over and over again. It really never wears out, and it's hard for people to go, oh yeah, right, buddy, sure, But
Mhm.
once you understand kind of how a catalyst works, that really is. We've had them out there over 20 years, and yeah, they're still going.
So
Mhm.
In fact,
we're
we
talking.
uh, we rec- we recommend to customers, when you get your new vehicle, take this thing off and put it on your new vehicle. Nobody remembers to do that, but yeah,
Mhm.
you can.
Well, if I can get paid back on an investment in a year, and it's going to last as long as the truck lasts,
Mhm.
that sounds like a hell of a deal. Even if I do forget to take it off and put it on the next one.
Yeah. I mean, in a lot of fleets today, kind of cycle through pretty fast. Have like a 2 or 3 year lease actually that they're working on, or they turn them back. Every 2 or 3 years to try to keep a new fleet, and that's fine. But yeah, if you're doing that, I would encourage you to remember to take them off. But again, if you
Mhm.
don't, even so, you got your investment back in one year, you've made all your money your second year, and then if you forget about it your third year, well, you've still made money.
Mhm.
Yeah,
Mhm.
and you're saving the planet as well. Uh, because God
If
damn,
you're burning, 3 to 5% less fuel, automatically you're producing 3 to 5% less carbon dioxide,
Right. Right.
greenhouse gas. Yeah.
Yeah.
and we've got to do so. John's heard me go down this one, and I'm not a huge environmentalist, but damn, we got to do something to save the planet because it appears
Mhm.
to me
Mhm.
like we're ruining it. So, uh,
Mhm.
My philosophy on that is, I don't really want to be affiliated with either fringe end of that whole thing.
Mhm.
But I don't throw trash out my car window either for that very reason, just because it's wrong.
Mhm.
You know,
Mhm.
and if we can do the right thing, we should be doing the right thing because it's the right thing to do.
Mhm.
And to me, polluting less is just the right thing. You can argue whether the climate change is our fault or not. I don't care. You still shouldn't be polluting if you don't have to.
Mhm.
We've
Mhm.
got solutions here. Let's use them.
Mhm.
and
Mhm.
it sounds like it's a very cost-effective solution. So,
It is, and one of the things I like to talk to, if there's any sustainability champions, listening or watching today, why don't you can have a sustainability project that gets you 3 to 5% carbon footprint reduced, but then you also be able to hand your organization a cost reduction at the same time. I mean, it's
Mhm.
a great win-win for sustainability people who usually get a lot of challenges and not a lot of budget to work with.
Mhm. Mhm.
Good option for that.
Yeah. 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 So I have to ask that devil's advocate question of,
Go for it.
if this technology is so good, why have the OEMs not taken this up and put this on as it comes down the assembly line?
Yeah, a very good question. I worked for one of the major OEMs for 20 years, so I
Mhm.
think I know how they think. They didn't they didn't invent it, right?
Mhm.
And so they don't want to be doing something that they didn't invent and that they are not in the profit stream of, just talking
Mm.
money here.
Right. Right.
Um, and the other thing is um, the corporate direction has been not to go after the OEMs, is to
Right.
get a
Right.
groundswell of users. You know,
Mhm.
Now, after there's enough activity in the market and enough of this getting around or whatever, there could be a Caterpillar or a Cummins or somebody who, wants to buy the company. And,
Sure.
who knows what the future could bring. But anyway, so for us, from the OEMs don't particularly want to embrace it. You also have to remember that it makes the engines last longer.
Yep.
Um,
Mhm.
and although everybody, all the major engine OEMs, they certainly want their engines to last long to give customer value, but they really don't want them to last any longer than the competitor either, because that
Mhm.
is where they
Mhm.
make most of their money is spare parts
Sure.
on engines.
Yep.
So we just
Yep.
just played economics, just being straight talk
Sure.
here.
Yep. Makes sense. Makes sense.
Yeah.
Yep.
oh boy, unfortunately, you are making sense.
Oh, hate it when that happens.
Brian, we got just a few more minutes left. What
Okay.
else do we need to know about either the company that you're representing or the product itself?
Yeah, I could go down just a few bullet points of
Sure.
3-year warranty. Um, we also have a $1 million guarantee against
Hmm.
any problems. Once you understand the technology, you realize this can never ruin an engine. But we have $1 million policy, so if we ever ruin an engine, that's covered. Although we've had that policy for over 20 years and never used it, so that's that. Um, I would offer also, if anybody is interested, to drop in. I've got a website set up. I'm at Zelcam.com, but I've got kind of an offer going at decarbonize5.com. And that's on the trucks, we usually get like 3 to 5%. And in larger equipment like mining and whatever, we get 5 to 7%. And I'm not exactly sure why there's that difference, but it's been pretty consistent that way. So one way, five's right in the middle. So decarbonize5.com, and you can go there and get a quick idea of what it might be worth for your fleet.
I'll make sure that Decarbonize 5, as well as your company website, both websites will be listed in the show notes down below, as
Great,
well as your
great.
contact info, so that people.
Yeah, that'd be perfect, man.
Yeah.
I'm really open to talking to people about this.
Sure.
You hopefully I've let you know I don't take myself too seriously either here, and I'm an easy guy to talk to. Yeah, set up a call and let's talk about this. See what it could do for your fleet. This
Well,
is serious stuff. It works.
Hmm.
well, if I could save 5% on my fuel bill, that's huge. Never mind the other benefits for the planet. But
Right? Yep.
and the other part that I will say is you explain things so that even I could understand them. So,
Well, yeah, I might be a chemical engineer, but I wasn't the sharpest chemical engineer.
He's got a touch of common sense.
Yeah.
oh God. Well, that's a great spot to wrap up. I'll make sure all those
All
show
right.
notes are sorry, I'll make sure your info is all in the show notes down below. And thanks, Brian, so much for joining John and I this week.
Yes, thank you. Great
It's
information
been a,
because
it's been a great
making me
time,
think.
guys. Thanks. Really
Yeah.
appreciate it.
And of course, I was Brian Livingston from Zelcam.com. Brian, a chemical engineer who explains things so that even I can understand them. His info is in the show notes down below, and I hope you check him out. Thanks for joining John and I this week on the Trucking Risk and Insurance Podcast. We'll see you again next week. And don't forget, if you're getting some value, leave us a comment, click like, and subscribe. Safety Dogs out.